welcome back. Today we're going to be taking care of a couple of 3D printing projects that have been on my desk for a while. First up, the wife wants a new knob for the dryer. One of the knobs that operates the start and stop knob is broken, so we're going to make a new one with a 3D printer. So we're going to be using FreeCAD 018. Here's all the build information on the version that I'm using. Working in the part design workbench, and as always you'll need to start with a body container, and we'll start our sketch on the XY plane. Make the base of the knob real simple, just a circle, and we'll give that a radius constraint about 23. And we'll pad that up 3.25 millimeters. We'll go ahead and fill at this edge, this top edge right now, because FreeCAD's not going to let us do it later with the geometry that we're adding on top of it. And then we'll sketch on top of that, and this will be the center of the knob. One of those up there. We'll go ahead and grab the external geometry. That's this button right here. Also the X button on your keyboard. Hotkeys are very valuable. We'll fix both of these points on that line. That is, where is that button? This button. Fix a point onto an object, or Shift O, which is what I'm using. About a 3 millimeter radius on that. And then down here at the bottom, similar but larger. We'll connect these. And then I want this to be nice and smooth, so we're going to use a tangent constraint. It always pops up this warning: endpoint to endpoint tangency was applied, the coincident constraint was deleted. So just in case you're wondering what that is, as it pops up all 4 times. And then the bottom of the knob center, I don't want to protrude past the perimeter here, so I'm going to add a coincident constraint onto that line, fix it onto this line. Oh, got a redundant constraint somewhere. There we go. And that line. And this bottom has a 7 millimeter radius on it. So you can see, since we're lit up green, we're fully constrained, so we can go ahead and pad this out. And we're going to use 2 dimensions. The first one goes up and the second one goes down. So we're going to go 26 up and 3.25 down to get us down to the bottom of our knob. Now we need to round off the top. So in order to make it symmetrical, we'll have to use a datum plane. So if you select the shape, and then in the part design menu, create a datum plane, and we're going to attach that with the object's YZ attachment mode, and create a sketch on that. So jumping back to the model tree, we can make that datum plane invisible, and then we'll grab these 2 lines to have some external geometry, and we'll base some construction lines off of that. So now we don't need to see our pad shape here at the moment. So switching over to construction line. This line is going to be the top of the knob, which I want to be about 26 millimeters from the base of the knob. And then we'll start making our shape. So these points we want just outside of the end of the knob. So if I bring the shape back into view, you can see we're well outside of it, but we only want to be just outside of it. And the reason for that is FreeCAD does not like pocketing on coplanar curves. It creates a lot of messes. So I always go just a little bit past the perimeter. And here it's going to be about 25.5. See our points just outside. And we'll do the same on the back here at 23.5. Yeah, we can probably bring that in a little bit more. 23.25. And then the back of the knob, that curve ends a little bit higher. This one we want lower, so we're going to set it right in line with the top of the base of the knob, 3.25. So now we can get rid of that shape just using the space bar to toggle its visibility. And we'll move this around until we have our shape. So we want to be below that 26 millimeter construction line, and that's about the shape that we're looking for. So now all we have to do is draw a closed shape around that, because we want to cut our shape into that. So I'll use the polyline tool to draw a generous box around the outside of it here. Close it, and we'll clean those up a little bit. Sweet. So now we can pocket our shape. You don't need to have every sketch fully constrained, just as long as you know what it's doing. Then we'll pocket that in 2 dimensions so it's symmetric. And we'll just go 50-50. And we still want to round things off a little bit more, so we're going to fill it this top edge, go 3 millimeters. That looks nice. And then this edge here as well, give that a little fillet. So now we got our nice smooth knob shape. Oop. Guess we need to add that in here on this side. Nice. So now, last little bit, the important part of the knob is where the post goes. So this little bit is a cylindrical shaft with a flat side, and the flat side is on the left as we're looking at it now. So we're going to start with an arc off of the origin and put a flat side on it. So this has a diameter of about 6.4 according to my calipers. We're going to give it a little bit oversized, so we'll just go like 3.3 radius. And then the length of this flat side, we'll set it 5.1. And I'm going to pocket that as deep as it can go to make sure the knob seats on there as far as we want it to. So let's try 25. Oh, that's a little bit too far. Let's go down about 2 millimeters from that. So now we're ready to plug this into our slicer and send it to the printer. But before we do that, we'll get rid of those extra lines that we don't need. And the way to do that is select the shape, and we'll switch over to the part workbench, and in the part menu select refine shape. And it got rid of all the excess lines that weren't needed to make the shape. And then we'll export that. Just call it knob. And pull that into Cura. That's a nice looking knob. And what I've got loaded in the printer right now is True Blue Polylite PLA. So that's what I'm going to be printing it with, just for simplicity's sake. Save that to the desktop as well. And then we'll take this through OctoPrint to the printer. So upload that here. A little bit of lag there in my view, but that's okay. So while this is getting going, I'm gonna start on another project. This one's a little bit different. We got a bunch of pictures of dimensions, and the goal here is to make a little bumper for this gate. A, so that it doesn't slam so easy, and then B, so that there's a little barrel lock on the back end of it that you kind of have to slide the gate back and forth until it lines up. So the goal here is to make a little bumper so that they can just close the gate without it slamming, and that have that barrel lock already lined up. So I'll jump back to part design workbench and start a new sketch inside a body container. We're also going to use XY plane for this one. And this one's going to be stupid simple. I like to have everything centered on the origin. So I always use, see, auto remove redundance there. I always use symmetry constraints, and that makes it so the origin is always in the center of your part. Use it on two sides. And here we're looking for 19. Here we're looking for 31. We'll do it a little bit undersized. Close that. We'll pad that out to 5.5 just to give it a little bit of space. With 3D printing, especially with TPU, which is what this is going to be printed out of, it tends to come up a little bit over the dimension. So really stupid simple. I'm just going to print that in some brown TPU. It's from NinjaFlex, made by Ninja Tech. They had a skin tone line, and I picked up a bunch of rolls of that on the cheap. And I'm trying to find uses for it. is a little bit more difficult. So slice that so we can get rid of that. Select our material. These are very common changes that I make to these profiles. Combing mode off, it tends to mess with the Z seam, and that's the point where it starts. Each vertical layer can usually be seen as a pretty prominent line across running vertically across the print. You can scatter it out, but I like to line it up. I turn combing mode to off. Z seam alignment is set with coordinates, and then we have wall thickness is modified to match the thickness of my nozzle. We'll change that because we're going to be changing our line widths for TPU just from experience. So there's just a little snapshot of everything that I had modified on that Polylight PLA high-speed profile, and I was getting really good results with it. So we'll go ahead and keep those for now. On flexible material, I really like using gyroidal infill. A, I think it's neat. B, it sounds really cool when the printer's printing it, making all those little wiggly shapes. And you'll see what I'm talking about here in a minute. But always connect the infill lines. It reduces the number of retractions. But for this one under quality, see our line width is set to 0.4, which is the size of my nozzle. Printing with NinjaFlex and other TPUs, I always set this over the size of my nozzle, and that causes it to push more material through there. I get fantastic results this way. But in material, by default, they have the flow cranked way up there. I don't think this works quite as well as changing the line width to be just a little bit more than your nozzle. I think that tends to be a little bit more consistent. So we're going to go 100 and 105 on the initial layer. Oops, one's already in there. Everything else should be pretty well set. We'll go 2 lines on this one. Sorry, my computer is slow. And it's a little old, so we don't quite get to see the nice layer view that comes with the later versions of Cura. I'm stuck in compatibility mode because my graphics card on this computer does not support OpenGL 4.2 or greater. So there you can see the gyroidal infill. I think it's really neat. It is, it's very even, and as far as strength and durometer, just makes the part as easily compressed from every direction. I like it. I think it's neat. Just a neat infill. So we'll wait for the printer to finish printing the other one. We'll flip our glass and PEI sheet over, so print directly on glass, and swap out the filament for that brown TPU. Let's go see how it fits. Hey, it fits perfect. Kind of matches the color scheme too. That was not planned. Sweet. Well, one done. Looks like it turned out pretty good. So this gate is actually at my mom's house, which is about 40 minutes away from us, so it'll be in another video or image where we actually see how this turned out, probably in the next 3D printing vid. So if you made it this far, thanks for watching, and see you next time.